Hello everyone. In this video I am going to discuss about the functional dependency. It's a very important topic in database management system where the students get some bit of confusion. So I am going to discuss about the functional dependency, what exactly it means, and how we differentiate between the trivial and non-trivial functional dependency, what exactly trivial and non-trivial functional dependency means by various examples. Now we'll try to understand what is the meaning of a functional dependency. So first of all, we'll see the definition which is mentioned in our textbooks. So if there is there is a functional dependency alpha to beta, it's said to be hold if T1 of alpha equals to T2 of alpha, then T1 of beta must be equals to T2 of beta. So what exactly it means? T1 and T2 are any two arbitrary triples and alpha and beta are the attributes. So in order to understand it, I have taken one example. There is a table or a relation having two attributes, enrollment number and name, where alpha is indicating the enrollment number attribute and beta is indicating the name attribute. So I'm going to take any two arbitrary tuples. So in this arbitrary tuple T1, the value of alpha, T1 of alpha is 105, T2 of alpha is again 105. So this if condition holds good. Now we'll test whether if T1 and alpha equals to T2 of alpha, then whether my T1 of beta equals to T2 of beta or not. So here T1 of beta is A2 and T2 of beta is A3. So these are not equal. So I cannot say there is a dependency from alpha to beta. Again, I'm taking one more example to make it more clear. Again, I have picked two arbitrary tuples T1 and T2, where the T1 of alpha is 105, T2 of alpha is again 105. So T1 of alpha is equals to T2 of alpha. So prerequisite condition is satisfied. Now I test T1 of beta must be equal to T2 of beta in order to hold a functional dependency from alpha to beta. So let me check. So T1 of beta is A2 and T2 of beta is also A2. That means in this case, in second case, I can say there is a functional dependency from alpha to beta. So in order to summarize, if we get same value of beta on every same occurrence of alpha, as we have seen in the second case, when my T1 of alpha is 105, T2 is also 105, then I got similar value of beta. At T1 is it was A2, in T2 again it was A2. So if we get same value of beta on every same occurrence of alpha, then beta is said to be functionally dependent on alpha, and directly we can say, in other words, there is a dependency from alpha to beta. So now we'll see some examples in order to understand the concept of functional dependency in a better way, and it will help also in the competitive exams and university exams as well. So there is one table AB having five attributes A, B, C, D, and E. There are certain tuples, and now we have to test whether which of the functional dependencies are holding good or not. So first of all, there is a functional dependency from A to B. So I need to identify any two arbitrary tuples where the value of attribute A is same. So in this case, this first tuple is having value A, and in tuple this third tuple also the value of attribute A is small a. So hence the first condition is satisfied if T1 of alpha equals to T2 of alpha. Now I have to see for the beta, and beta, since attribute B is the beta, so here the value of T1 of beta is 2 and here it is 3. So there, that means T1 of, in spite of T1 of alpha equals to T2 of alpha, but T2 of beta is not, T1 of beta is not equals to T2 of beta. That means 2 is not equals to 3. If it would have been equal, then we can say there is dependency from A to B, but now this is value 2 and this is value 3, means on the same value of alpha, I am getting different value of beta. Here it is 2, here it is 3. So this functional dependency A to B does not hold. Now we'll test for A to C. A is and this C. A for A it is 3 and for A it is again 9. Though we have one tuple A3, so A3, A3, but at this value of A, I am getting 9. So again this A to C will also not hold. Next functional dependency is C to A. C to A at this value 3, I am getting A, 3, I am getting B. So hence the condition violates. I must get same value of beta on same value of alpha. So here alpha is C, 3, 3, I must get A. Then I can say yes, there is a dependency from C to A, but now I am getting at this 3 value, I am getting A, at this tuple I am getting value B, so beta is not matching, hence this is also not holding good. Now combination of attribute CD to E, CD 3 4 3 4, the two combinations are same, 3 4 3 4. Now see the value of beta, so 3 4 5 3 4 again 5, so I am getting same value of beta for same value of alpha. So this is holding good. D to C, DE 4 5 4 5, and we'll see the value C 4 5 3 4 5 3. This is also holding good. E to D, E values 5 5 5. Let me see. Well, for all 5 the values are in the attribute D must be same. For this E it is 4. For this 5 this is 4, this is 5, this is 4, and for this 5 this is 6, hence this will not hold good. AB to C, AB, A2, and this is also A2. So for this A2 the value is 3, for this A2 the value is again 3, so this is also hold good. So in this way we can check whether a particular functional dependency by looking towards a particular table will hold or not hold in context of that particular table. Now we'll see one more example in order to understand the functional dependency. So again there is a one table having 5 attributes and some tuples, and I need to test whether these functional dependencies holding good or not. First of all, dependencies A to B, C, here alpha is A and beta is B and C combination of the attributes. So A is, I need, first of all I will pick the similar values of A, those tuples. We have similar values of A. So here the value of A is small a, this is small a, this is small a. Now we need to see the combination of B and C. So combination of B and C, for this A it is 2 3, for this A it is again 2 3, for this A again it is 2 3. That means this is correct, this holds good. Now DE to C, DE 4 5, again 4 5. Now we will see the attribute C. For this 4 5 the value is 3, for this 4 5 again 3, this is also hold good. C to DE, all the values are similar. So DE, for this same this 3, this is 4 5, this is 4 5, for this is 6 5, doesn't hold good. If I get all the values same for similar value of C, then I can say there is a dependency. But here all the values of C are same, but I am getting variation in the values in D and E. For this 3 it is 4 5, this 3 it is 4 5, that's fine. But for this 3 the values are of attribute D and E is 6 5, so it doesn't hold good. Now B, C to A, similarly if we check, we can say this is also hold good. So in this way we can check the functional dependencies. So now we'll see one more example and we'll try to form a rule. So if you see this set of these dependencies, at the alpha side I am getting only A, and now we'll see look towards the attribute A. In attribute A all the values are different. As we can see, for first tuple it is A, for second it is B, for third one it is C, and for fourth one it is D. So if it is so, if if I am getting all different values of alpha, then all in spite of any attribute on the beta side, all the functional dependencies will hold good. Because I need to test for beta if I get two arbitrary tuples with similar value of alpha. So in this case, none of the tuple is having similar value of alpha. Therefore, all these functional dependencies will hold good. Remember, this is the rule. So more specifically, if alpha to beta is a dependency and all values of alpha are distinct, then remember every dependencies hold good. Now we'll see one more example. This is a table and I'm having a set of functional dependencies like this. In the earlier example, I am having only one attribute at the alpha side, but now I am having only one attribute at the right hand side or at the beta side. But if we look at this attribute in this table, all the values of this attribute C are similar. So remember this rule, if the value at the beta side is having similar values in the table, then irrespective of any value on the alpha side, all the functional dependencies will hold good. Because both of the conditions for functional dependency, they will be satisfied, and hence we can draw one rule here. If alpha to beta is dependency and all values of beta are same as we have in our case, if all the values of beta are same, then every dependency irrespective of any value, any attribute on left hand side, they will hold good. So now we'll see what is the difference between the trivial functional dependency and non-trivial functional dependency and what it means and what is their significance. So suppose there is a functional dependency from alpha to beta, and if beta is subset of alpha means, if for example there is a dependency AB to B, and we can see this at the beta side B attribute is already available at the alpha side, means all the attributes at the beta side are, if they are available on the alpha side as well, then we can say this kind of functional dependency is trivial in nature. However, it is not useful too much because it genuinely, if we say, if I tell you your name and means if I ask you, you tell me your enrollment and name, I will tell you your name. So it is of no use because that attribute I already know. So that means if I know the value of attribute A and B, then I can identify the value of B. Obviously, one can identify because B is already available at the alpha side. If it is not so, if beta is not a subset of alpha, means there are some attribute at the beta side which are not available on the alpha side. In that case, we can say this functional dependency is non-trivial in nature. So basically in database management system, we deal with the non-trivial functional dependencies. So for example, A to BC, all these two attributes B and C are not available in the alpha side, hence this A to BC is a non-trivial functional dependency. We'll see some couple of examples. Are these functional dependencies trivial? So these are the functional dependencies. A to AC, beta side, C is not available on alpha side. That means this is this functional dependency is not trivial. We have to test whether they are trivial or not. This is not trivial functional dependency because trivial needs all the attribute at the beta side must be available on alpha side. Here BC, both are available on the alpha side. This is trivial. X, Y to Z, this is again non-trivial because Z is not available. A, B, Z, A, B are available but Z is not available. So this is again not trivial functional dependency. C to AC, A is not available, not trivial functional dependency. A, B, C to B, B is available. There is only one attribute at the beta side and that is available. And this means this is a trivial functional dependency. B, C to Y, Z, again it's clearly seen visible YZ are not available on the alpha side, this is also not trivial functional dependency. So hope you enjoyed this video, and if you have some queries and some questions, you can mention in the comment box. Thank you for watching this video.